All right, so today we're taking notes on Objective 3.1c. 3.1c, this is day 1. And our topic for today is in your footer of your notes at the very bottom. So you don't have to write the topic down. Down at the bottom of the notes it says solving quadratic inequalities. Okay? Your instructional objective, I will be able to solve quadratic inequalities and choose the sign chart method that helps to determine the solution set. Solve quadratic inequalities and choose the sign chart method that determines the solution set. All right, so I'm going to be using some very specific terminology today. So our vocabulary today is the word zeros, also known as roots, solutions, and in some cases x-intercepts. These 4 terms are actually interchangeable terms. You'll have professors and teachers that use different terms. But for today's lesson, I think the zeros are the most impactful. That's the most impactful term for solving a quadratic inequality. So here's what a zero is. It's the numbers that replace x to make an equation equal 0. The numbers that replace x to make an equation equal 0. For example, I gave you x plus 2 equals 0. What does x have to be in order for that to equal 0? -2. So we would call -2 a 0. That's what we would call it, because the -2 is the number that zeroes out that equation and makes it equal 0. Okay? So we'll be looking for zeros often today. They help us to determine the boundaries of our answers or the constraint numbers. Okay, so ready? We're going to start with a process that you will follow. And if you follow it carefully, you should have some great success today with your assignment. So we're going to start with step 1. In quadratics, when you're solving a quadratic inequality, the process that's always the best is to rewrite the inequality in standard form. So standard form of a quadratic is x squared plus c. Since it's an inequality, I can say it's greater than 0. But that, of course, isn't the only way. We would also want ax squared plus bx plus c is less than 0. And of course you could have less than or equal to or greater than or equal to. But you want the quadratic part of the inequality to be in standard form. Okay? All right, after we do that, which is a pretty automatic process, right? You guys just automatically are putting I can say this word, quadratics in standard form. All right, so after we do that, we're going to turn our brains. That says brain. You're going to turn your brain to the on position, because now the automation is going to stop, and you're going to have to think, because you have to now determine, now that it's greater than 0 or less than 0, if you're looking for a positive, excuse me, or a negative interval. So you have to think about what that means. Does that say Brian or Bren? That says brain. That says brain. Okay. Woo, I'm getting old and sometimes I forget. Okay, I left some space under here just so that we can think about it. So if our answers are going to be positive, that means that we're looking for numbers that are greater than 0. If we're looking for intervals that are positive, we're looking for numbers that will create numbers that are positive, greater than 0. Correct? Because positive numbers are greater than 0. There's another greater than that we could talk about. And that's greater than or equal to, right? And when we have greater than or equal to 0, we're looking for positive numbers that are greater than 0, but we're also looking for what? We're actually looking for 0. So in this situation, we're looking for the positive intervals, and we're looking for 0. Okay? So those are the two greater than situations where your brain has to think, okay, I'm looking for positive values here. All right? And then, of course, the opposite is also true. If I'm looking for negative intervals, then I'm looking for numbers that are less than 0. If I am looking at less than 0, I'm looking for negative intervals. And the last choice, of course, is negatives and 0, which would be less than or equal to 0. So those are our 4 situations that we will encounter when we're solving these quadratic inequalities. So when it's a greater than, our focus is positive intervals. When it's a less than, our focus will be negative intervals. Okay? So now what we're going to do is we're going to solve the quadratic, and for our purposes, for the next, I don't know how long, our quadratics will always be factorable, because we don't want to gum it up with imaginary answers and decimal approximations. We want exact, beautiful answers. So for math analysis purposes, we will always have factorable ones. When you get to pre-calc, it gets a little hairier, meaning a little more difficult to navigate, but most of the time they'll still be factorable. All right, then after we factor out our quadratic, we're going to find the zeros, because we need to know what numbers are going to make our inequality equal to 0. They are our boundary numbers. Okay, so these are our boundary numbers. We want to know them. It's important to know what are the boundaries of our solution, our boundaries of our positive intervals and our boundaries of our negative intervals. Want to know those numbers. After we do that, we're going to create a number line with our zeros. Okay, a number line with our zeros. And then we have to engage our brains again. We're going to choose sign, and I don't want the word method here, sign chart 1 or 2 to identify positive and negative intervals. Okay? And once we get that done, we're going to go back to step 2 and look at which one we wanted. Positives or negatives, brackets or parentheses, you know? And then we're going to take our answer from our number line and we're going to write it in interval notation, because we're going to choose the intervals that have the answers we're looking for. So this is our process that we're going to go through. Have these note page handy when you're doing your assignment today, because you're going to want to refer to the steps. You're also going to want to refer to the notes on the sign charts. Okay, remember that your whole goal today is to be successful here, to ask questions when you have them. And after we get finished with the notes, you're going to choose whether you prefer chart 1 or you prefer chart 2. I will tell you that at some point I'm going to want all of you to transition to chart 2 because it's faster. The only thing about it is that it's really abstract, meaning it's hard to visualize what it means, because there aren't any numbers involved. It's just negatives and positives, and it's a bunch of signs. But when we start doing rational inequalities, and here's what I mean by that. Like if I have that, which we're going to do next week, you're going to want sign chart 2 to get to the answer really a little bit more efficiently. But before I throw a quadratic in the denominator, let's just focus on a quadratic by itself, okay? All right, are you ready? So step 1, is it in standard form? All right, so step 2 is to engage our brain. What kind of numbers are greater than 0? So we are looking for positive intervals that will be greater than 0. So I'm going to highlight that with my highlighter. We are focused, oh, that's the wrong highlighter. I don't want blue highlighter. I want yellow highlighter. Positive intervals. That's what we are focused on. So we have to keep that in our mind as we're working through this problem. Okay, so next step says that we're going to factor the inequality. I don't want yellow. All right, so x squared minus x minus 6. And since I want to find the zeros, I'm going to make it equal to zeros. That's how you find zeros. You have to make it equal 0 to find your zeros. Okay, so we're going to factor. Yes? And you can factor using your AC method and your AC chart. So what's your top term? Negative 6. What's your bottom term? So you're looking for the factors of negative 6 that add to negative 1. Well, he has to multiply to 6, so you have choices. 1 times 6 or 3 times 2. So what do you think? Negative 3 and positive 2. All right, now since our A term is 1, we don't have to go through the process of writing it out in 4 terms, grouping it, cutting it in half. We just take our x term. We're going to open up our binomial pairs. You're going to break up your x squared into x times x. And then you're going to take your two numbers that you found, negative 3 and positive 2 equals 0. And you have factored that quadratic. When your A is 1, that's what you do. Now let's find our zeros. So x minus 3 equals 0 and x plus 2 equals 0. And what do we get? X equals 3, x equals negative 2. All right, so those are our zeros. So we're going to create a number line here. Something that I noticed, let me just say this real quick, that I may not have given you enough room, if you really want to take good notes, to fit both sign charts here. So if you want to put this sign chart above the line and put the other sign chart down in your summary section, you can just put your summary on the back. Okay? So you don't have to worry about space so much. All right, so let's do our number line. I would put it here, but I don't want to be at the bottom of the graph, so you can put it underneath. So here's what we're going to do. We're going to create a number line, and we're going to take our two boundary numbers, our zeros, negative 2 and 3, and we're going to break up our graph into 3 intervals. Because we don't have an equal to sign, we're not including our zeros in our answers, right? So that would be parentheses. So what I'm going to do is on the negative 2, I'm going to just tack parentheses on it. I don't know if I want this side of negative 2 or if I want that side of negative 2 at the moment. I'm going to do the same thing with 3. So now what I want to note for you today, that of course you don't have to write down after this time, is that you've created 3 intervals. This section right here is interval 1. From negative infinity to negative 2 is interval 1. This is interval 2, this little space right here from negative 2 to 3. And then of course from 3 to infinity, you have interval 3. Now it might be interval A, B, and C. That doesn't matter. Just to distinguish what between the different intervals, okay? All right. So what we're going to do is we're going to start with a number, a set of numbers to help us to choose this. Of course, we could use our calculator to do this, but you might not have a calculator at home, so we're going to do the notes. So we're going to pick numbers from each interval to plug into our quadratic, okay? Now, would you like to plug them into this part, this version of the quadratic, or this one? You pick. I don't care. Do you want to plug numbers in here and here, and then multiply the answers, or you just want to plug in x's here and here? Standard form. Okay. So what number do you want to pick? Okay, so let me make my table. Excuse me. So I'm going to make a table where I take x. Here's my chart. And then I take x squared minus x minus 6 per your choice. And we're going to get an output, which we're going to call the y. And then after we do that, we're going to determine, is our answer, does that make our interval that contains this number that we pick positive interval or negative interval? Okay, so you choose a number that's in interval 1. Keep it really close to the 0 so your numbers aren't crazy big. -3. So we're going to choose -3. We're also going to choose a number between -2 and 3. And I always say if you can choose 0, that you choose 0. So I'm going to dictate this time that for this interval, well, since 0 is in interval 2, we're going to choose 0. And then we're going to choose one more interval or number from interval 3. What number would you like to choose? 4 or 5? I don't care. 4. All right, so we're going to choose 4. So what we're going to do now is we're going to determine if interval 1 creates positive numbers or negative numbers by actually plugging those values in. So I'm going to go -3 squared minus -3 minus 6. And I'm tucking parentheses around those -3's as I substitute them in. Okay? And when I do that math, folks, I get the answer positive 6. Right? Because 9 plus 3 is 12, and 12 minus 6 is 6. So that means that this is a positive interval. So what I'm going to go over here to my number line is I'm going to go ahead and say that all the numbers in interval 1 will produce positive results if I plug them into my equation. Because isn't this true? And is this true? Is 6 greater than 0? Yeah, so you know what? I want that interval, right? So you know what I'm going to do? I'm going to put a little happy face right there because I want that one. That one makes me happy. Okay, now I'm going to say something really powerful right now. I'm plugging in a 0 into the quadratic. So that means my answer is going to be the C term. What's the C term in my quadratic? So that you believe me, I'm actually going to plug it in. But anytime you plug in 0 for x's, that eliminates the ax squared, right? Because what's 0 squared? 0. All right. And what's minus 0? And so 0 minus 0 minus 6 is -6. So that's why we like to pick 0 every time we can, because that gives us what we want pretty much right away. So that's going to create a negative interval, because when I plugged in 0, I get a negative number. Okay. Now lastly, I'm going to plug in a 4. So 4 squared, 16, minus 4, 12, minus 6, 6. So that produced another positive. So I forgot that I was on a path right here. So when I plugged in my purple 0 in my purple section, I got a negative. I don't want that. Because a negative will not satisfy my inequality. It will make it false, right? If I were to plug in a -6 is greater than 0, well, that's a bad answer. So we don't want that as part of our solution. Okay, last one, erase, was the 6, right? And the 6 is in interval 3, so that makes a positive interval, and we want that. We definitely want that in our solution. Okay, so now we need to write our answer in interval notation. I think I'll go ahead and highlight my answer. This is a good section of my graph, and this is a good section of my graph, because those sections produce positive numbers when I plug them into the inequality. So what's my solution in interval notation, people? Starting at -∞, approaching -2, but not including, in union with, because we got to jump over the gap, non-inclusive 3, 2. You guys are so good. All right, so that's method 1 or chart 1. And so what we're doing is we're looking for this information here. We want that information because that helps us to determine our solution. Before I move to the second sign chart, I would like to answer your questions. So, do you have them? Because if you do, I'd like to pause the video. Okay, Jonah. So here's your second option. So I've erased that problem, and we're going to do this with a different method, and we're going to use the sign chart, and it's actually just built of a bunch of positives and negatives. We'll tell you that your next year teacher in pre-calc will teach it this way. She will not teach it with the numbers. So at some point we want you to transition to this. When you're comfortable, you will. You will decide sooner than later that you prefer this. All right, so how we create this one is a little different. So it's a process that you have to learn. What we do with the second sign chart is we take our factored binomials, x minus 3 and x plus 2, and we stack them, one on top of the other. This is just an organizational tool, okay? And it doesn't matter if I put the x plus 2 on top and the x minus 3 on bottom. That doesn't matter. You just stack them. And then right here beneath them, you're going to create your number line, and we're going to put our zeros in. So it's the same process as the other one so far, except that we're stacking our zeros. Okay? And then because we're doing greater than and not equal to, of course we're going to separate our zeros with our approaching signs, because we don't want to include 0 in our answer, so that we can see interval 1, interval 2, and interval 3. So now, here's the part that you really need to ask questions about if you don't understand. What I want to do is I want to go to my top row, my first number in the stack, and I want you to tell me what makes this equal 0. What number? What's the 0? So over here above 3, I'm going to stack a 0, because 0, 3 makes my first binomial equal 0. And I'm going to then draw a line, just a dotted line, right there, to break this side of my number line away from these two. Then I go to stack number 2, and I ask, what zeroes out this one? -2. So I'm going to put a 0 right there for the second one. Okay, now I'm going to start filling it in with bunches of positive signs and negative signs. This time I'll explain it. You ask questions if you don't understand, and after today, I'm not going to explain it. But you can still ask questions if you don't understand. Okay? Do you understand me? That was a lot of understanding that I just said that you needed to understand. Understand? That was a good one. Okay, just kidding. I only make me laugh. Okay, so what I want to do here is, again, I want to pick a number like we did before. I believe we picked -3. Correct? So if I plug a -3 in this binomial pair, I get -6, right? So that a -3 produced a negative answer. So I'm going to fill that in with a negative. Then I'm going to jump to interval 2. And I'm going to say I'll pick 0. 0 minus 3 is -3. So that's going to be another negative interval for my first binomial. And then if I plug in a 4, 4 minus 3 produces a positive 4, or positive 1, excuse me. Okay, so intuitively, let's just think about this. This is my 0. On all number lines, to the left of 0 aren't my numbers negative, and to the right of 0 aren't my numbers positive. So that would, I think we should be able to intuitively go decide what kind of number am I going to get here to the left of 0? Negative. What kind of, this is 0, right? To the right I'm going to get, and to the right I'm going to get even more positive. Now we'll plug in numbers just so that you can trust it. So plug in a -3. -3 plus 2 is -1. Yeah, they're different zeros. So that shifts their number line back and forth a little bit. If I plug in a 0, 0 plus 2 is +2. If I plug in a 5, it's positive. So intuitively, once you learn how to find the zeros, to the left of each 0 creates negatives, and to the right of each 0 creates positives. And that's per line. Now, I have a bunch of signs. They don't mean anything until I do this final step. So I'm going to draw your attention back to my binomial pair. What am I doing to these two things here? I'm multiplying them. Yes? So a negative times a negative equals a positive. So this forms a positive interval. And guess what I want? I want that. because I'm looking for a positive interval. Let's go to the next section. Negative times positive gives me a negative interval. You know what? I don't want that. You don't have to do happy faces and sad faces, people. All right, then positive times positive produces a positive interval. So once I have decided what kinds of intervals this sign chart's producing, I go back to my equation and it says that I want positive intervals. So that means I want this section and I want this section of the number line. So to write that in interval notation, I want interval 1, correct? Interval 1, which is negative infinity approaching negative 2. I don't want interval 2, but I do want interval 3. And this is just a different way to determine the types of intervals you're creating. Once you learn the process, it's a really quick way to get to the answers that you want. But I want you to understand it. So if the first sign chart made more sense, stick with it for a while until you can trust the sign chart number 2. Do you have questions about this? Yes. What signs? All right. So for the last part of this lesson, and you don't have to take notes on this part, I'm just going to connect what we were doing to this parabola that I have graphed. This is actually the parabola representing x squared minus x minus 6. And what I'd like you to notice is my x-intercepts. What's my 0 right here? What's my 0 right here? Positive 3. Now, since I want greater than results, what I need to do is look at the sections of my parabola that exist above in positive y. So you can see, or hopefully you can see, that these sections going to negative infinity, right, as I go left, I go to negative infinity, that I'm getting positive numbers. I plug in a negative 2, I get a 0. I plug in a negative 3, I get out a almost 5. I plug in negative 4, I don't even know, it's way up there. Okay? And also, this section exists above the line. So I'm looking at that way, and I'm looking at that way to be my solution. And then when you look down here at this selection, these are all negative y's, correct? So down here, let me change colors here. Down here, my answers are negative. Between here and here, I get negative, whereas over here, I get positive, and over here, I get positive. So a connection to the parabola. Okay? Questions about that? Oh my gosh, the bell's going to ring, and we are not done yet, which is not good. Okay, so let's do this one, and let's go quickly. All right, so here we have number 2, and it is not in standard form, so let's go. X squared plus 3x is less than negative 2. Move the negative 2. X squared plus 3x plus 2 is less than 0. Engage your brain. That means we're looking for what kind of numbers? Oh, you know what? Let's go back and put an equal sign in there, just so that your notes have an equal example. You know, a less than or equal to example. Okay, so what kind of numbers are we looking for? Negative and the 0. We want both of them. So that's our focus this time. We're looking for, you can kind of see my answers here, kind of letting you look at them. I'm going to move that out of the way. So, ready? We're looking for that. So let's factor. Open your factoring pairs. X and x. What numbers multiply to 2 and add to 3? 1 and 2 equals 0, right? And we're going to factor. So, or we're going to find our zeros. So x plus 1 equals 0. So x is negative 1. X plus 2 equals 0. So x is negative 2. Negative 2. Thank you, Andrew. Negative 2. You are so right. I need you guys so much sometimes. All right, so we're going to go. You do chart 1 or you do chart 2. You choose. I'm going to do both of them here. I have to create my number line to create my intervals though. So I need a -2 and a -1. And this time, am I choosing brackets or parentheses? Because I'm including my 0, I want my brackets. I just don't know which section of the number line I want to pick. I think intuitively when we look at the graph, we can decide we want this section, right? The negative section. Okay, so I'm going to do the sign chart. So what numbers do you want to pick? -3? Yes? Yeah. I think -1.5, because that'll be in the center. And then 0, right? And you know what I think? This time I'm going to plug it into the factored form. So I'm going to do x plus 1 and x plus 2. So -3 plus 1 times -3 plus 2. Well, -3 plus 1 is -2. -3 plus 2 is -1. So -2 times -1 is positive. Is -2 times -1 is positive 2. So that's my y, which produces a positive interval, right? So we don't want that. No, we don't want that. Sad face. Because we want negative intervals this time. -1.5, I'm just going to give you the answer. It's -1/4. Okay, which produces a negative. I would just plug that in. -1.5 plus 1 times -1.5 plus 2. That's going to produce a negative number because that's -1/2 times +1/2, which is -1/4. So we want that, yes? So we want that section. And then if I plug in a 0, I always get my C term, which is 2, because 0 plus 1 times 0 plus 2 is 1 times 2 is 2. And that's positive. And I don't want that. So my solution, -2 to -1. Oh, I don't have time to do the second chart. Yeah. Okay, let me press pause.
Okay, your other option is method 2. Making my video. Don't pay attention to me. My method 2. Which is the other sign chart, which if you recall, we would stack our factored binomials, one on top of the other, and then create a number line below, and plot our zeros, which are -2 and -1. Go back to the inequality to choose if we're going to use brackets or parentheses. Because we have an equal to sign, we're going to include the zeros, so we'll use brackets. And then we're going to identify the zeros. So the zeros for x plus 1 is -1. So we'll break up that interval. And then for our x plus 2, make my 0 purple. And so -2 would create 0 there. So we'll break it up. So we have interval 1, 2, and 3. Now we're going to go put in our signs. So for x plus 1, if we plug in a -3, that would create -2. If we plug in a -1.5, that would create a -1/2. If we plug in a 0, we get a +1. For the second one, if we plug in a -3, we get -1. If we plug in a -1.5, we get +1/2. If we plug in 0, we get 2. So now that we've got our sign chart created, we're going to use our signs to determine what kind of intervals we have. So we multiply just like we multiply here. Negative times negative creates positive. And this time, we don't want that. Negative times positive is negative. And so we do want that because we want less than. So we want that section. And then positive times positive is positive. And we don't want that. And so because we're looking for the negative interval, we want to use these numbers that are between -2 and -1. Those are the solutions that are going to give us, that's the interval that's going to provide numbers that are negative and will satisfy this inequality. So our final answer, including our zeros, our solution is from -2 to -1 inclusive. Right? And then, of course, the last thing I want to do is just bring in the parabola that is developed from this quadratic. And you can see the zeros here. And you can also see that the negative solutions are between -2 and -1. And that's it for today's lesson. Thank you.